All right, welcome to the YTAC programming. This is week 5, technically, as far as our curriculum goes. We've had last week was just the Rocket League tournament and our associated Choose Your Own Adventure game, which went very well. Good submissions all around. And I'm glad everyone got a little bit of change of pace, a little tiny break from cryptography, but we're going to go right back into it. With the next cipher on our list is the Vigenere cipher or the Tabula Recta. This is a very old cipher, but the funny thing about this is that it is the first one we are doing this class that is a polyalphabetic cipher. Polyalphabetic simply means it has multiple alphabets. It's not just shifting around the letters. And as you can see here, I have this big 26 by 26 grid on the screen. And basically how it works is instead of just taking a number and adding it to your letter, you're taking the position of another letter and adding it to your letter. So, for example, you can see here if we go to B and then we take it to other B, it's matched to C. If this is our plain text up here, and this is our what's going to be called a key, then you would just say, okay, B is the second position, and then B is the second position, but remember this is in Python, 1 is 0, and the second position would be 1. So 1 plus 1 would be 2, which is the third position in the alphabet, which is C. And this whole big graph table just goes through and has all the things so that you can do it manually, which was how this cipher was originally produced. So the way it works is you have a key and your plaintext, as I've mentioned. So your plaintext could be something like cryptography. That's what you're trying to decode, or you're trying to encrypt and then send to someone else. And then the key, it's not a number this time, it would be like a word or a small phrase or a couple of letters. You could have your key is DK. You could have your key, for this example, I'll say it's YTAC. So basically what makes this key important is that you can see here if we went through C to Y, we'll just look at this chart. C, Y, we take that's A. And also, just so you know, it does not matter which side you use. It is a mirrored grid, as in if you have A to Z, it's still Z, and if you have Z to A, it's still Z. So we're going to go through it and we're going to look. Okay, what's the second one? R and T. We're going to find R and we're going to go down and we're going to find T. T is this column right here. R is this K. Then we're going to do the same thing for the Y. Y and A is just Y. And we're going to do the P and the C. Take the P, go down to C, and that is just R. Well, now our key is no longer reaching out. What do we do here for the rest of the message? Unless we want a key stream that is the exact same length as the word cryptography, that could be, this would be a problem, and same thing if we had over. So basically, to get the actual what you'll use, YTAC is the key, but we're going to use a key stream. So basically a key stream is just the stream of the keys in the most literal way. So basically what will happen is we'll take it and then we'll just go through and we'll fill up until we're out of characters, until we've matched all the ones that it needs. So you can see first YTAC, second YTAC, third YTAC, and then we needed a Y to go through. So I would go through the rest of this example, but it's pretty menial labor by hand. It's just, and that's why we're going to, for this week, we're going to create our Python language so that it can do it for us. And our cipher will be taking in a text and a key. So, like I said, basically what we're doing here is we're taking the position of this letter, adding it to the position of this letter, and what's not really apparent by this graph, but then you modulo 26 like we've had to do with the other ones. So for example, if you take z plus b, that's 26, because normally it'd be 27, but we're in Python. Modulo 26 is 1, so then that'd be a. And you can see where it would go over to the other side. So basically, this one you're going to take the position of your plain text, position of your key stream, and then you're going to add them and modulo. What I will show you is how to generate that key stream, because it is not very self-explanatory. You're going to want this inside your Cipher function. You can see I have it down here at the bottom, and it is hidden because that is the assignment for this week. But we're going to go through and we're going to have our key stream finder. Normally, you would have your define your function, whatever you have in there, and then what we're going to put is basically what's going to be inside this function at the first part of this Vigenere, Tabula, Recta, and Cipher. So the first thing we're going to do is we're going to take our letters. We're going to need all the letters, which is unfortunately just going to have to, I wonder if I have it in here with this text clean. Do I have it in the block message? No, unfortunately. These are the same code from earlier that we've used in this course. We're going to go through A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. There's our alphabet. That's the first thing that we're going to need to have. So basically, if you remember from looking at this, we have to know how far to go. So what we're going to do is we're going to make a counter that will add the next letter and the key to it. So what we'll do is we'll say counter equals an integer, right? Because we're going to have to divide here, and we don't want it to be a decimal. That's not helpful. Len, which is just the function for length, open parentheses, our text, which we do not have now. I'll just go ahead and make this a function. Let's call it key stream, and then we're going to have our text, comma, key, and then we will take this, and then bam. So we have in our letters here in our counter, before we get this going, we have to finish inside of this counter where we divide the length of the key, and then we're done with that integer value stuff, plus 1. That plus 1 is again because we are in Python where counting starts at 0, so we're just going to want to refresh that and have that plus 1 to be sure. So basically what this function right here does is it will take the length of the text, divide it by the length of the key, and then add it to 1. Essentially what we're going to do is we're going to have a while loop. We haven't had any while loops yet in this class, but here is the first one. But before we do that, we're going to want to have our key stream. Like we have our outputs earlier, we're going to have this open bracket here. And after this, we will go down, have our while function, which basically says while a condition is met, it will loop through this. Once it's not met, it will stop. Versus a for loop, which is saying for this conditional, it will do it. So we're just going to have counter greater than 0. Because once the counter is greater than 0, it's basically saying they're the same length, which is exactly what we want to generate our key stream. While that counter is greater than 0, we're going to have our key stream. We're going to say plus equals, which is the same thing as saying key stream plus key stream, key stream equals key stream plus something else. That something else is going to be our original key that we put in. And then after that, we're going to take our counter, and we're going to subtract 1. Remember, this is only created one time. This doesn't refresh. This just tells us how long we need. What it will do is it'll subtract 1 once it adds another letter, subtract 1 after that, subtract 1 after that. And we're done with that while loop. And then we're going to take our key stream variable that we made up there, it's going to be equal to key stream, because we're generating it right now, 0 plus the length of the text. So this is some notation that we haven't really used a whole lot. Basically, if you remember from earlier when we said our alphabet, and then we'd have our square brackets, and we'd say the number, which would take you to the position in the alphabet. We did this with the Caesar cipher, we did this with all the other ones. Basically, what this will do is it will enable this to have a range that we're going to. So we start off with 0 because we want the start of key stream. We're looking at the inside of key stream, starting at the first variable, the first letter in it, going all the way to the letter of the text. So if our text was 5 characters long, it would go from the 0 to the 5th character in that. And basically, what we want this to do is just repeat however long our our plain text is for our key. Like if we look back to this example, we have this many y tacks, and this is basically what it's doing, is it's trying to find, okay, we need to have 3 and 1 letter of y tack in order to fit it there. So we're done here. We're just going to return key stream, and then that should be good. We have an error message here. We can debug that if we need to, but let's go for the print, and then we're going to say key stream create, and then we're going to have our text be cryptography will be our text, and then just like before, our key will be ytac. Now before we go into this, it won't quite work because we have this issue, and that's why we have this text clean function in here. So we're going to go back to the start of this, and we're going to say text equals text clean of our text. In addition to that, we're also going to do key equals text clean of key. In this example, our key is all uppercase, it's all cleaned, but we just want to have that there in the future just in case we don't have that, or if our key is something that's not just one word. For example, if we go over here, we can have our plain text is basketball is my favorite sport, and then our key could be but soccer is good too. And that way, whenever it goes through, it'll remove the spaces, it'll make everything capitalized, and then it'll go through that process. When you have this longer key, it will have more room that it will need to take up, and it'll have to have a longer message for it to really be very effective. So this is a fairly difficult cipher to break, but it does have some weaknesses. Unlike those mono-alphabetic ciphers we've done, like Affine, Caesar cipher, or whatever, they had 26 possibilities. This one, you have 25 times 26. So if we have that, and that's because we have the different choose from this letter on this side, choose from this letter on this side, except if we have the same, original thing, it'll be the same. That's why it's not 26 times 26. But let's try and run this and see what we get. And there is our key stream. ytac, ytac, ytac. So you will need to have this implemented at the start of your code for your Vigenere cipher and decipher, which will mean you're going to want to have something like define cipher text key, don't forget your colon, and then you're going to want all of this stuff right here. You take all this, and then you're going to start going with your output equals open stream, and then you're going to go into the rest of the code, which I have laid out, and you can rewatch this video. This will be on YouTube very shortly, and I will put it in the Discord. Excuse me. If you have any questions, feel free to DM me. And just a reminder, I will also have this Tabula Recta available for you if you do want to reference it and kind of see how it works. The assignment is to just make the end cipher and decipher. Now, I will tell you for the decipher, it's just the same process but backwards. So for example, if we take this example right here, we're going to have this, and we say we know the key stream, we know the key is YTAC, and we know what the ciphertext is. Well, if we look through here and we go backwards, we say we know what Y is, and we know it's A. So that's, I'm sorry, I have it backwards. You look at Y, and you find A on the list for your ciphertext, and then you see where it was. C. You have your T, and then you find K. K is right here, this white line, and that's D. Wait, had it backwards again. You have K, and then the T, and then you see this is in line with R. So it's a little bit different, but it's essentially, instead of adding them, you're subtracting with the product. So your assignment is to create an end cipher and a decipher tool for this. That will give you your one entry. But wait, there's more. If you create a brute force Vigenere cipher that will just say, I don't know the key, this is the ciphertext, find the plain text. If you can create one of those, then you will gain an extra entry for this week. I will review how this cipher is coded in Python next week in class, and I will be releasing videos throughout the week to help you if it's needed. I hope you all accomplish this well. Good luck, and let me know if you have any problems.